Exercise 5 is the following. Consider a free market with demand equal to Q equal 900 minus 10 times P and supply equal to Q equal to 20 times P, where capital P is the price and Q is the quantity. In sub-exercise A, we're asked what is the value of consumer surplus, what is the value of producer surplus. Okay, so it makes sense to not only calculate those values, but to also derive a graphical representation of what the consumer surplus and the producer surplus actually is. So let us start with the formulas first. So we have a demand function which is equal to the following. So we have Q is equal to 900 minus 10 times P, and supply. So let's put a D here. So this is the quantity demand. So then we have the quantity of supply. So I think they're not on the exercise sheet, but just to distinguish them, think of them as supply and demand here. So supply is 20 times P. And what we need to find out, okay, the first step is we need to find out the equilibrium price. So the equilibrium price, so the price where demand is equal to supply. So demand should be equal to supply. So then what we have is 900 minus 10 times P is equal to 20 times P. One reason that we can do this, I should have mentioned this, of course, is that we assumed in the exercise that we have a free market. Okay, so we have a free market, and this means that nobody is interfering, at least for now. And yeah, the market is basically going to its equilibrium, at least in this model. So we're setting those expressions equal. And if we then calculate this expression, what we end up with is then that we have a price which is equal to 30. So if you solve this, P star, which is the equilibrium price, is equal to 30. And therefore, so this is the equilibrium price. And therefore, since demand and supply are equivalent in equilibrium, we can plug in this price into either demand or supply. What we get is Q star is equal to, let's take the supply. So 20 times 30 is 600. So this is the equilibrium quantity. Okay, so what makes sense now is to start with the graphical representation of what consumer surplus and producer surplus is, and then we can derive from this the formulas. So it makes more sense to do it in this way. Okay, so what we need is the so-called choke price and the reservation price. So those are the reservation price is the price above which demand is equal to 0, and the choke price would be a price above which the supply is equal to, so below which the supply would be equal to 0. So we need to, first step, we need to get the intersections of demand and supply with the x and y axis. Okay, so the first question is, or let's do another enumeration here. So first, when is demand equal to 0? Okay, So when is the demand equal to 0? For this, we need to find out the price such that demand is equal to 0. And if you take a close look here, demand is 900 minus 10p. So if we insert a price of 90, we will have 900 minus 10 times 90, which is 0. So p, so we'll call this p upper bar. At p upper bar equal to 90, demand is equal to 0. Okay, so at p equal to 90, demand is equal to 0. So if the price would be higher than 90, there would be no demand in this economy. Then the next question would be, what is demand at a price equal to 0? So this is the saturation. I think it's called saturation quantity. So what is the amount which is demanded by the consumers if the price is equal to 0? For this, we simply set the price equal to 0, and then we have 900. Yeah, so it's 900 minus 10 times 0, and this is 900. So then QD, let's also call this QD upper bar. QD is, oh no, it's a little bit confusing with the price. Never mind it. We just call it QD. So QD is equal to 900. Okay, so we have now the intersections of the demand function with the y and the x-axis. Now we do the same thing for the supply. So when is QS equal to 0? Okay, so when is the supply equal to 0? For this, we basically look at the supply function, which is 20 times P, and this can only be 0 if the price is equal to 0. Okay, so then we would have at P, let's call this lower bar equal to 0. Okay, and that's actually all that we need. We don't need to find, so there is no intersection of the supply function with any of the x's. Basically, it's going to the 0 point, so there is no intersection with the x's. So it's enough that we know that the supply function starts at 0 and then it's going to infinity basically if the price is increasing. That's all the information that we need. So why did we do this? Now let's go to a graphical representation. So let's draw a coordinate system. So let's draw a coordinate system where we will have the demand or the quantity. The quantity will be on the x-axis and the price will be on the y-axis. So what important points do we have? So first of all, like one of the most important points here is the equilibrium point. So at a price of, let's call it here it's 30. This is the equilibrium price. At 30, what we will have is a quantity, an equilibrium quantity of 600. So this will be the first point, which is kind of the point where demand and supply are intersecting with each other. So then what do we need next? So the first thing that we derived here on the right-hand side was the price above which the demand is equal to 0. So let's draw this point because it's fairly easy to draw this. So this would be somewhere, yeah, it's not very correct here, but it would be somewhere here. So at a price of 90, so the scales are not correct here, but actually it doesn't matter to make the point. So that at this point here, 90, what we have is, a demand of 0. Then at a price of 0, what we will have is a demand of 0, a demand of 900. So this would be somewhere around here. I'm just drawing it such that we can connect it. Okay, it's a little bit above, but let's just presume the point is here. Okay, so the point is here. This is the equilibrium point. Okay, this is the demand function. So this is QD. Then the supply function, we know that it starts at 0 and it's a linear function which goes through the equilibrium point. Therefore, we can simply draw a line like this. And this is the supply function. So QS. So this is the equilibrium point here. And now we have a very nice graphical representation for the consumer surplus and the producer surplus, because the area between this dashed line that I just drawn and the demand function starting from 90 going to the equilibrium, which is this area here, this is the consumer rent. So we'll call this CR. Sorry, 1 second. CR. So this is the consumer rent. Okay. So what is the consumer rent? So the consumer rent is basically aggregating the money that all the individuals saved when buying the product because they had a higher willingness to pay for the product than the equilibrium price. Okay, so everybody who's buying the product and has a higher willingness to pay for the product than 30 is, you can say, saving some money. Yeah, so he would have paid more for this good, but he has to pay 30. Therefore, there is kind of a difference between the willingness to pay and the equilibrium price. And if we aggregate all of those differences for each individual, then we end up with the consumer rent. Yeah, so this is the consumer rent. The same thing for the producer rent. So the producer rent is here. This is the producer rent. This is producer rent. So while the heterogeneity on the side of the consumers was with respect to their willingness to pay for the product, the producers are heterogeneous with respect to their costs. Okay, so they have different costs for producing the good. Therefore, in equilibrium, there are firms who are selling the product, but who have lower production costs than the equilibrium price. So they make profit. Okay, they make profit out of selling. And if you sum up all of those profits, what you end up with is the producer rent. Okay, so of course, in this model here, you need to consider that there could be also fixed costs. So the producer rent is always profit minus the fixed costs of the firms. And this is represented here by this triangle in green here, which I just showed you. Okay, so this is consumer rent and this is producer rent. So let's now, if you look at it graphically, it's very easy to see how we can actually calculate it. So we need this area of the triangle for the consumer rent. So what do? So we take 90. So let me just write it like this. So the consumer rent, I'll write it in red. So the consumer rent is 90 minus 30 times 600. So what do we have now? So we have 90 minus 30 times 600. This would give us let me just change the color. This would give us this rectangle here. This is what we would get. So this is the area of the rectangle, 90 minus 30 times 600. But we are interested in the triangle. Therefore, what we need to do is we need to divide this area, this rectangle, by 2. And this will give us the consumer rent. Okay, so this is the consumer rent. And if we calculate the values, we end up with 18,000. So this is the consumer rent. The same with the producer rent. So the producer rent is this triangle, which I showed you before. So this is then 30 minus 0 times 600. And then we divide it by 2 as well to get the area of the of this triangle here. So please don't confuse it the producer end, just to make sure, because when I'm looking at it right now, it might be confusing. It's not, it's this area here and not this area. Okay, so just to be sure that you get this. So 30 times 600 divided by 2, this should be 9,000. And then we can calculate the total surplus, which I will call TS. So TS is the total surplus. This is simply adding up consumer surplus plus producer surplus and is equal to 27,000. And this was sub exercise A, if I'm not mistaken. Yes. Yeah, so basically the statement here is that the monetary amount of the money that the consumer with a higher willingness to pay than the equilibrium price saved relative to the equilibrium price is 18,000, and the profit of firms on this market which have lower costs or lower variable costs than the equilibrium price is equal to 9,000 if we ignore fixed costs. Okay, so let's come to sub exercise B. So in B, we are asked the following. So before we had a free market, and now what happens is that the government is imposing a $15 per unit subsidy on the production of the good, which means that for every good that is sold or that that suppliers put on the market, they get $15 from the government. And then we ask what the consumer surplus is now and what the producer surplus is. And the other question is why we have a debt weight. Look, if we have a debt weight loss, why we have this kind of a debt weight loss. Okay, so let's go back. So what we need to do now is we need to find out the new equilibrium price. So a subsidy, you can think of this as kind of adding up on the price or the price that the supplier get in case of selling it. Okay, so it basically lowers the cost of production of the goods. So the new supply function is now given by the following. So we'll call this QS. This is not 20 times P, but it's now 20 times P plus 15. Okay, because for each price which is determined in the market, the supplier will get an addition of 15 to it. Yeah, so this is the new, and of course they know this, so they anticipate this, and this is the reason why we need to incorporate this into the supply function. So now new equilibrium. So the new equilibrium is now setting again the demand function equal to this new supply function. So there are no subsidies on the sides of the demand function. Therefore, there is no change. So we simply set QD equal to QS. And then what we have is 900 minus 10p should be equal to now, if we solve the bracket, we have 20 times p plus 300. And if we solve this, we end up with p star equal to 20. Okay, so p star is equal to 20. And therefore, if we enter this into either the demand function or the supply function, what we end up with is a quantity traded, which is equal to 700. So using the same formulas that we derived before, we can now calculate the consumer and the producer surplus. So now the consumer surplus, so new surpluses, so new consumer surplus, we call this CR, is now the following. So it's again 1/2 times now 700 times 90, which was the price above which there is no demand anymore, which we calculated before, minus 20. And this is equal to 24,500. So this 24,500, this is the new consumer surplus. And the new, we also have a new producer surplus. So the new producer surplus is the following. So it's 1/2 times 20 plus 15, so the equilibrium price plus the additional 15 monetary units of subsidies times the amount which is supplied, which was 700, and this is equal to 12,250. So this is those are the new surpluses that we have. But in addition, of course, there is a kind of an additional thing here. When we have subsidies, of course, there are costs of subsidies. So we have costs of subsidies. So the cost of subsidies are basically the equilibrium amount which is traded times the monetary amount of subsidies. So it's 15 times 700, and this is equal to 10,500. 10,500. So we need to consider this because obviously the government needs to get the money from somewhere. So when it's thinking about incorporating the subsidy and thinking about welfare comparisons, it needs to, of course, incorporate the costs of subsidies into the comparison. So now we have the new consumer rent, we have the new producer rent, and we have the cost of subsidies. Therefore, we can calculate the total welfare, so the total surplus. So the total surplus is 24,500 minus 12,250. Plus, so consumer rent plus producer rent minus the costs of subsidies. So 10,500. And this is equal to 26,250. Yes, so and if you compare the total surplus here that we have with the subsidies and you compare it with the total surplus that we had before, which was 27,000, you can observe that the welfare now is lower. Yeah? So the subsidies that the government imposed basically on this market yielded at the end, if you consider the net effect, lower welfare than yes, the free market. And there is a deadweight loss, which is then the difference between the welfares here. So it's 27,000 minus 26,250. So we have a deadweight loss, which is right below here. So I will call this debt. DWL is the deadweight loss. So deadweight loss is 27,000. So old total surplus minus new total surplus, so 26,250. This is equal to 750. And what is the reason for this deadweight loss? So this is actually an efficiency loss. So there is an efficiency loss because trades are induced for which the actual resource costs without the subsidy is greater than consumers' willingness to pay. Yeah, so by the subsidy, what you do is you artificially decrease the costs for the suppliers, but actually, if you wouldn't have imposed the subsidy, then some of the consumers and some of the suppliers wouldn't have traded, which means that by the subsidy, you make inefficient firms be active on the market and sell their products to consumers who, if there wouldn't be the subsidy, actually have a lower willingness to pay than the costs of production for those inefficient firms. Therefore, there is an efficiency loss here, which basically describes or explains why we have a deadweight loss. Okay, so this was everything with respect to exercise number 5. So let's come to exercise number 6. So exercise number 6 is a utility maximization exercise. So we are given some goods, we are given some income, some prices, and a utility function, and we are basically asked to solve the optimization problem of the consumer. So here in this particular example, we have $4,000 to spend on entertainment. So we have a day trip or pizza and movie, and the price of a day trip is equal to 40, and the price of pizza and a movie is equal to 20, and our utility function is given by this expression here. So the amount of day trips by the power of 3/4 times the amount of pizza and movie by the power of 1/4. And the question in A is, what combination of T and M will you choose? This is what we will be doing now. So let's write down the optimization problem. So what do we do? So we use calculus. So we're using first order conditions or optimization with a constraint to solve this optimization problem. So what we want to do is, or the person wants to do the following. So this is question number 6, A. So the person or you want to maximize over the amount of day trips T and the amount of pizza and movie, which is capital M. And what do you want to maximize? You want to maximize your utility function. So T by the power of 3/4 times M by the power of 1/4. Okay? This is what you want to maximize. But of course, if there wouldn't be a constraint, the solution would be simple. You simply consume an infinite amount of both of the goods, or one of them, and some strictly positive amount of the other one. But of course, there are constraints in the world, so we need to incorporate them. So how do the constraints look like? So we need to be sure that we do not spend more than we have. So what do we have? We have $4,000. So we must be sure that we do not spend more than $4,000. So the price of day trips, which is 40, times the amount of day trips that we consume, plus the price of pizza and movie, which is 20, times the amount, which was capital M, should be equal to what we have to spend for entertainment, so 4,000. Okay, so this is the budget constraint basically. Yeah? So this is the objective function. And this is the budget constraint. So the objective function is what you want to maximize, and the budget constraint is telling you what you're allowed to do, basically, if you want to have the most simple explanation here. So we can bring this. So there are many ways to solve this. You can use a substitution method. You can use a Lagrangian method. Since my solutions, they're considering the substitution method, I will simply use it. So what is the substitution method? So what you basically do is you rewrite the solution by substituting or substitution. I will just call the solution by substitution. So the first step is to rewrite the budget constraint. Oh. Okay, to rewrite the budget constraint. So what do? We can either rewrite it in a way that we have capital T as a function of everything else, or we have capital M as a function of everything else. So what I will do is I will solve the budget constraint for capital M, so for the amount of movies. So what we then have is M is equal to 200 minus 2T. And then the second point is substitute M in 1 into m in objective function. Okay, so what is the purpose of this? So by doing this, we get rid of one of the endogenous variables. So we get rid of capital M basically in the objective function. Okay, so what do we have then? So if we do this, we are maximizing the following. So then we have the following optimization problem: max over t, yeah, because you will see now that there will be no capital M anymore in the objective function. So max t, t by the power of 3/4 times, now if we substitute for capital M, we have 200 minus 2t by the power of 1/4. And the nice thing now is that since we rewrote the budget constraint, in that we derived a relationship between the amount of movies and what was t again, the day trips, the amount of day trips that we have in a particular way such that the budget constraint is fulfilled with equality, and we substitute it here, we can ignore it now. Yes, because if we solve this optimization problem, which I wrote down here, we can be sure that the budget constraint is always fulfilled because we only allow for solutions such that it is actually fulfilled. Okay, so the rest is actually calculus. So in the rest, what you do is basically you solve this optimization problem, and by taking the derivative and what you end up with, the solution. So the solution here, the solution will be t star is equal to 75. So if you derive the first order condition, okay, I can write down the like kind of the, so derive first order condition and solve for t. This then will give you t star equal to 75. So if you maximize your utility, given your budget constraint, you will consume 75 day trips in equilibrium. Now, the next step would be to find out what P is. So plug in T star into, what was it? It was M equal to 200 minus, what was it? 2T? Yeah. So plug in T star for T into, this equation here. And then what you get is M star is equal to 50. So the answer would be T star equal to 75 and M star equal to 50. So you would take in equilibrium, so if you maximize your profits, you would take 75 trips and 50 movie and pizza nights. Yeah, you would consume this. And this is the solution to sub-exercise A. In sub-exercise B, we have the following. So in sub-exercise B, the price of day trips rises to $50. And the question is, how will this change your decision? So obviously, since the goods that we're considering are normal, so in that they're really goods, and we benefit from them, obviously this will lead to a decrease of demand for day trips in this example here, yeah, because the price of day trips is increasing. But we will see this in a second. So actually, the only thing which will change then is basically the budget constraint. So let me just quickly copy this. So I can delete some of the stuff here. So what is the thing which changed here? Well, the price of day trips changed from 40 to 50. That's the thing which changed here. So it's 50 times t here instead of 40 times t. And then the rest of the steps is actually, yeah, it's basically the same as before. So then you use the substitution method again. So what you do is then m is equal to, now it's a little bit different here. So m is now equal to 200 minus, what is it, 4,000 divided by 50. Sorry, no, it's 50 divided by 20 is 2.5. 2.5 times t. Then, yeah, then maximize over t. What do you maximize? T by the power of 3/4 times 200 minus 2.5 times t by the power of 1/4. And now if you solve this, the solution for this is then given by t star being equal to 60 and m star being equal to 50. Okay, so this is the solution if the price of day trips increase to 50. So as you can see, what is changed here is only the amount of day trips, which I mentioned before. So the day trips are decreasing here, so the amount of day trips in equilibrium are decreasing because the price of the day trips is increasing. But at the same time, what we have is that the amount of movies, which is here in equilibrium, pizza and moving, is the same as before. And the reason is basically because of this type of utility function. So for those types of utility functions where you have two things multiplied to each other with some exponent, then what you will have is that this is in economics, this is called the cross price elasticity. So how does the demand of one good change if the price of another good changes? So for those types of utility functions which you have here, actually this will be always 0. So there will be no change in the demand of another good if the price of another good changes. And so this is the reason why m star is equivalent here as before the price increase. Okay, so this was everything which was with respect to the exercise session for today. So please let me know if you have any further questions. So this video will be uploaded on YouTube. I think I have 3 different parts. So I summarized 2 exercises into one video. So I have 3 videos in total. So you have my email address. So if there are any open questions, please let me know. You can also ask me questions with respect to the lecture. This is also no problem. And if you have any suggestions on how to improve the exercise, so I'm using a tablet for the first time, so I'm not that experienced with this. But if you have any suggestions to make, please also let me know. I'm open to improving the exercise sessions in the future. See you next week.